Types of waves. We have to start out by asking, what is a wave? Ultimately, a wave is just a transfer of momentum and energy. What makes this different than what we've studied previously with momentum and energy transfers is that there's no permanent transfer of mass. So the mass is not permanently displaced, it just oscillates around a point. We can classify waves based on how they're formed. So we can have a transverse wave. All right, this is what we traditionally think of as being in a wave. It's got that wave shape with a crest and a trough. And they can be horizontal or vertical, and in this case, they're on a slinky. You can also have longitudinal waves. And that's when I put a compression into a slinky and let it travel along the slinky. So in this case, if you want to help remember the two vocab words, trans means across, so the particles move across, and longitudinal, the particles move along and then oscillate that way. We can also classify waves based on what they travel through. So if a wave travels through a medium, we call it a mechanical wave. And that is all we're actually going to study in AP Physics 1. We study non-mechanical waves in AP Physics 2. A medium is the material in which the wave travels through. Sound waves travel through air, water, even a wall. That's why I can hear people in the hallway at lunch. There are some waves that don't require a medium to travel through. The most classic example is a light wave. Okay, since those are electromagnetic radiation, they don't require a medium, therefore they can travel through a vacuum. We can also classify waves based on how they travel. They can move in a circular motion, or they can move in a plane, like a geometric plane. So here's an animation that shows both types. All right, on the top, you can see the wave front moving upwards. Okay, so those arrows indicate the direction of the wave motion. Or you could have a point source for your wave, and the waves would expand outward. The wave fronts move out. So that would be like if I dropped a pebble into a lake, you would get those ripples moving outward. We will sometimes treat circular waves as planar at a singular location. So if you look at one of those arrows in the bottom part of it and look very close to the arrow, you can see that essentially right at that point you have what looks like a plane wave. We can also classify waves based on their source. So we have pulses, which is if I give a single pulse along, say, a string. Or I can have a periodic wave, in which I periodically, so at some sort of periodic time, I apply a pulse. And that ends up giving you periodic wave, which again is more what we think of as being a wave traditionally, and in our English language usage of the word, but really both of these are different kinds of waves. So here's our check for understanding question. All right, so fill in the blank. The material through which a wave travels is called a blank, and then give 2 examples. The answer is the material is called a medium, and water and air are both examples. Outer space doesn't have the material density to be considered a medium. That's why sound doesn't travel in outer space. And same thing with a vacuum. Here is the summary of topics in this video.